Good morning, Year 6. We're now going to start measuring using a protractor. It's Wednesday the 13th of May. So looking at our first anchor question, estimate then measure these angles. So to begin with, I know I have got two angles here. One is an acute angle and one is an obtuse angle. I know this is acute because it is less than 90 degrees. I know this is obtuse as it is more than 90. So I know 90 degrees would be straight up here, and the same with here. So a line straight up, 90 degrees with this line here. So I can see this is over and this is under. So I'm looking at, estimating, so if that is 90, I'm going to estimate that this is 45 degrees. And here I'm going to estimate that this is around about 130 degrees. So I then get my protractor, and as the line is this way, so I put my T point on the angle here, and as the line is this side, I start with the 0 on the inside. So I can see here that it's pointing to this 0, so I'm not using the outside measurement, I'm using the inside measure. So I can see here 0, 10, 20, 30, and I can see here that it is to the 5. So actually it is 35 degrees. Just change the colour, 35 degrees. So it's only 10 degrees out, not too bad. So then I look at the next one, and again, let me just move that back to 0, and I can move it down to this one. Again, I put my T joint on the angle, and I can see here 0 is on this line, and moving this across, I'm using the inside measure again, as that line is on the 0 on the inside, all the way around, and I can see it is around about 136 degrees. Not bad estimates there. So let's have a look now at the progress. I'm going to read through the questions. So for every 2 sweets there are 3. There are 30 sweets altogether. How many are there of each colour? What fraction of the shapes are triangles? Which is larger, 0.4 metres or 350 millimetres? And write 38/7 as a mixed number. And remember, tell this time to your little brother, mum or dad. Let's have a look at the video now.
Again, flashback forward to start us off. So do the 4 questions, pause the video, we'll come back together in a second. How have you got on? Number 1. For every 2 green sweets, there are 3 red. There are 30 sweets altogether. How many are there of each colour? So for that one, you should have got 12 green and 18 red. What fraction do the shapes of triangles? For every 2 squares, there are 3 triangles. So if I'm thinking of 5 parts, 3 out of 5 of them are triangles, which is 3/5. Which is larger, 0.4 metres or 350 millimetres? It would be 0.4 metres. Write 38/7 as a mixed number. You should have got 5 3/7. And the time on the clock is 17 minutes past 8. Okay, we're going to start looking at measuring with a protractor today. So we're going to watch carefully because we're going to see a line and another line appear. Did you see what happened? We saw that the second line appeared and it was turning from the first one. We can measure how far this line has travelled by using this little arc here. We call this an angle. An angle is the measure of the amount of turn between 2 lines. So this is a protractor. We can use it to measure the degrees of turn between 2 lines. You may have seen one before, but don't worry if you haven't, we're going to have a look at it together. Okay, we're going to see if we can use a protractor to help us measure the amount of turn that's gone between the 2 lines. Watch carefully, and I want you to think about how much turn we can measure. Okay, how much turn went through the first line to the second line? There's 2 possible numbers we could look at. We've got the ones in black, which is the outer scale, and the ones in blue, which is the inner scale. Which scale are we going to use to measure it in this case? Well, if we're thinking about starting from 0, we increase from 10 to 20 to 30 to 40. So in this case, we're going to use the outer scale to measure. In this case, the angle is 40 degrees. We can write this as 40 and the little degree symbol. We call this an acute angle because it's less than 90 degrees. What about this one? We're going to carry on the turn. Watch carefully. We're increasing the amount of turn now. And we stop. Have a little think. How many degrees turn was there from the 0 to where the line is now? We still want to use the outer scale, and we can see that it is now at this point here. If we're going to measure it, we can see it's between 80 and 90. In this case, the degrees is 88. The angle is 88 degrees. We call this an acute angle because, again, it is still less than 90 degrees. We've moved the line slightly now, and we can see that the new measurement is 90 degrees. This type of angle has got a special name, and we can represent it using this little square here. This shows us that this is a right angle, and that our right angle is worth 90 degrees. We're going to carry on. We're increasing the amount of turn. We went from 90 to 140. The new angle is 140 degrees. We call this an obtuse angle because it is greater than 90 degrees, but less than 180 degrees. Let's carry on. Still increasing the turn. And we're going to stop here. I wonder if you can notice anything. That's right, it's a straight line. The angle between the two lines is 180 degrees. We call this a straight angle. You might call it a straight line. Watch carefully. Something's going to happen now. Okay. There's a problem. It's gone past the limit of our protractor. Our protractor only measures from 0 to 180. I wonder how we can measure this angle now. What happens if we measured the size of the angle from 180 degrees? Well, we knew the straight line was 180. And this is an extra 40 degrees on top of that. And 180 degrees plus 40 degrees is 220 degrees. We call this type of angle a reflex angle because it is greater than 180 degrees. What about looking at examples of them? Let's look at some examples of acute angles. All these angles are less than 90 degrees. What about obtuse? Here are a few examples. They're all greater than 90 degrees, but less than 180 degrees. What about straight angles or straight lines? We can see that all these are equal to 180 degrees. What about a reflex angle? Remember, these are greater than 180 degrees. Pause the video, have a go at question 1. We're going to go back to our protractor again now. There's a few parts of this that are going to help us measure. This part here is called the origin. It looks a bit like the sort of the sun on the horizon. We place the origin on the vertex where two lines meet. Let's have a go ourselves. We want to place the protractor's origin where the vertex is. Can we see where the two lines meet? Let's place it. There we go. Our origin is on the vertex where the two lines meet. Another key thing is that the baseline, which is this line here, is placed on one of the lines. That's showing us where our 0 is. And now we can measure. Now then, what is the size of the angle? Is it A, 155, B, 145, C, 45, or D, 35? Pause the video, have a think for yourself. Okay, let's have a look. A, 155. Well, as we can see, it looks like it's 150 and a bit, but actually, this is an acute angle. It can't be 155. And for that very reason, because it's less than 90 degrees, it can't be 145 either. What about 45? I can see it's a bit to the right of 40, but when I notice I'm looking at the inner scale, I can see that it's between 40 and 30. So it can't be 45. D. It's halfway between 30 and 40. That's the correct one. It's 35 degrees. Here we go. We've got three angles, A, B and C. But which is the greatest angle? Pause the video, have a think for yourself. How did you get on? Perhaps to check this, we could measure. Let's get our protractor. Placing the origin in the vertex and the baseline on one of the lines, we can see that the size of this angle is 40 degrees. What about B? Placing the origin, and I can see this one as well, is 40 degrees. One more time. Let's place the origin where the vertex is. I can see this again is 40 degrees. So that they're equal sized. Even though the lines are larger, the degrees of turn between the two lines is exactly the same. Okay. Pause the video, have I got the rest of the questions? If you don't have a protractor, don't worry about doing question 3. Hello there again. Flashback Forge starts off, so
have a go at the rest of the sheet. Remember, log on to Learning by Questions and answer those questions as well. Good luck.